When you write a program, you're typically going to be working with input, processing, and output. They exist in almost every program. Input is what you get from the user or from a file, but somehow you have to get data for the computer to work with. Processing is what you do to that data. And then output is what you do with the data, displayed on the screen, save it to a file. It's what you've done with the data. And we were going to work with two primary ways of planning at this stage of our work. We're going to get to the unified modeling language later. Today I'm going to show you how this would work for pseudocode and for flowcharting. With pseudocode, we're basically making an outline of what we're going to do. And I like to break my pseudocode into sections that may repeat, because you might have a program that has different levels of processing. For each section, I like to start with the data that I'm going to need for that section of the program. So let's take a look at capturing the area of a circle. We all know the formula for this, but if you don't, it's pi r squared. So if we're going to calculate the area of a circle, what we want to do is we're going to have some data that we define for the program. So we'll define pi, and we'll have that equal to 3.14. So this is a variable, but it's actually considered to be something called a constant, a variable that doesn't change while the program is running. R, that's our radius, is going to be our input. And so when I want to get input from a user, I usually just I usually put it in as get radius. That would be my variable. It's input from the user. The word get tells me I'm getting it from somewhere. R squared, that's part of our processing. R squared is part of our processing formula. So once we have our data, then we can process it. So we would take pi and we would multiply it. We can use parentheses here if we want to, because we should square r first. So we'll take radius, which was my variable name. And to square it is to times it by itself. And we would multiply that, and that would give us an answer, which we would usually assign this formula to an answer. And so answer becomes a variable. A variable is a place, a named spot in memory where we store data, and I'll talk more about that in a minute. And then we would have output, where we would display to screen. So that's the logic if we're doing pseudocode. If we were to represent this in a flow chart, we don't represent this part in the flow chart, our constants, but we would do input. And our flow chart would start with the program name. So it would be named circle. And then we would go into input, and the symbol for input and output is the same one. It's this sort of angular rectangle or parallelogram. And so that would be, we don't need to say get because the shape indicates that. So it would be radius. We'd do our calculations, our function, which is a rectangle, pi r squared, or we could represent that with the variable name. We would represent doing output, which we'll put on the display, and then we would indicate the end of the program. Both of these are valid planning tools, and you can choose to use either one. I personally will do most of my examples with pseudocode because it's the way I think and what I prefer. But you can use any of them, and you'll see me use both in lectures throughout the course.